Hello dear students, I am Dr. Debashis Bhowmick, Professor in Physics in Julelal Institute of Technology. Today the topic of discussion will be crystal structure. Crystal structure is one of the very scoring unit of your Sem 1 engineering physics. So let us see what are the different aspects of crystal structure. Crystal structure. The word structure means arrangement of atoms in any material, more precisely in solids. Now we can classify solid in two different types depending upon their nature of atomic arrangements. One of them is amorphous and another one is crystalline. You might have studied this differentiation in your intermediate 12th standard, that amorphous solids are those solids in which the arrangement of atoms are very random. So random arrangement of atoms results in an amorphous solid. Like example, chalk is an amorphous solid, graphite is amorphous. So many in day-to-day life you will find many such examples which are amorphous in nature. The glass is also amorphous. As far as crystalline nature is concerned, the solids in which again the arrangements of atom are very systematic. So systematic arrangement of atoms results in a crystalline solid. Many examples of crystalline solid. Semiconductor is a crystalline solid. Diamond is a crystalline solid. So by these examples you can very well distinguish, you can very well make out that the amorphous solids are not strong solids. They are weak solids because of their random arrangement. Whereas the crystalline solid are very tough and strong solids because of their regularity in the arrangement of atoms. If we can classify, if we want to classify the crystalline solids, so crystalline solids are classified into monocrystal and polycrystalline. These are the two different types or you do classifications of crystalline solid. When we talk about monocrystal, mono means single. So what is monocrystal? Monocrystal stands for if the symmetry of arrangement of atoms, is same all over the solid, such solids are called monocrystalline solids. I am drawing a very simple schematic of a monocrystalline solid. You can see all the atoms here in this part, in this sample, small sample, all the atoms, they are very regularly arranged. Each atom has a very definite space and the symmetry throughout this solid, whatever portion I have drawn, is absolutely same. So that is why this type of crystalline solid comes under the category of monocrystal. You can call it a single crystal as well. What is a polycrystalline solid? In polycrystalline, this is an example of monocrystalline. In polycrystalline, let me draw. There are some solids in which the atomic arrangements are not very regular as monocrystal. You can see I am drawing some symmetry. You can say that these solids are definitely regular in arrangement, but as you can see the regularity is changing. Here we have a triangular symmetry, here we have a square symmetry. So in solids in which such different symmetries, such different varieties of symmetries are there, such solids comes under the category of polycrystalline solid. So solid, as we have classified, amorphous and crystalline. Amorphous, very haphazard or irregular arrangement of atoms results in an amorphous solid. But crystalline solids are those solids in which the atoms are very regularly arranged in the space. There are two classifications, monocrystal and polycrystalline. If in a solid, all the atoms bear absolutely identical symmetry throughout the solid, thus it is called as monocrystalline. And if the regularity changes, although it is regular in some part, but the regularity is changing, the symmetry is changing, such solids comes under the category of polycrystalline solid. Thank you.